Good morning, sir. This is P. Tejashwani from Srinivasa Ramanujan Institute of Technology from the Department of Electronics and Communications, and my roll number is 234G1A04B8. Today, my topic for the presentation is Uniform Linear Arrays. This topic is from the subject Antennas and Wave Propagation, and the subject code is 23ECE502. This is my presentation topic, Uniform Linear Arrays. Introduction to Uniform Linear Arrays. Uniform Linear Arrays is simply called as ULAS. Uniform Linear Arrays consist of multiple antenna elements spaced evenly along a straight line. They are widely used in applications like radar, wireless communications, and signal processing. Uniform linear arrays provide a simply yet efficient way to steer and shape antenna beams for improved performance. Basic structure of uniform linear arrays. A uniform linear array is composed of identical antenna elements arranged in a linear fashion with uniform spacing. The element spacing is usually less than or equal to half the wavelength to avoid spatial aliasing. The array's geometry significantly influences its radiation pattern and directivity. Array geometry and parameters. Key parameters include the number of elements n, element spacing d, and array length. Typically, element spacing is set to d equals to lambda by 2 for optical performance. The array's phase and amplitude execution determine the overall beam pattern. Array factor concept. The array factor describes the combined effect of all elements in the array. It is a mathematical foundation that models the pattern found by the array. The array factor depends on the number of elements, their spacing, and steering angle. Beam forming and steering. Beam forming involves adjusting the phase and the phase amplitude of each element to direct the main beam. Uniform linear arrays can electronically steer their beam direction without physically moving the array. This capability enhances target detection, taking, and spatial filtering. These are the advantages of uniform linear arrays. Uniform linear arrays offer a simple and cost-effective solution for directional signal transmission and reception. They provide high directivity and gain with the relatively few elements. The uniform spacing simplifies analysis and implementation of beamforming algorithms. Limitations of uniform linear arrays. Uniform linear arrays are susceptible to grating lobes if element spacing exceeds half the wavelength. They have limited azimuthal coverage and can be affected by mutual coupling between elements. Physical and practical constraints limit the maximum size and element count of the array. These are the applications of uniform linear arrays. Uniform linear arrays are used in radar system for targeting, detection, and tracking. They are integral to multiple input, multiple output. Multiple input, multiple output is simply known as MIMO, communication systems. Uniform linear arrays are employed in satellite and wireless sensor networks for spatial diversity. Recent advances and variations in uniform linear arrays. Adaptive beam framing techniques enhance uniform linear arrays capabilities in dynamic environments. Sparse and thinned arrays reduce the number of elements while maintaining performance. Hybrid array designed combine uniform linear arrays with other configurations for improved flexibility. This is all about my presentation. Thank you.